Um, Hi. Morning, guys. I know it's not morning, but I just need a second. So this is a digital microscope. And as I connect this to the computer, I can walk you briefly through it. It has a camera on top, and then a microscope lens on the bottom, and the current configuration, 5 times magnification. Oh, and also. Okay, and now, when I say 5x, you may think that, oh, 5 times magnification. All of our phones today would say 5x, right? It would say 5x magnification when you're on the camera. But no, I will tell you that this is not the same 5x magnification. Here, what I'm talking about is an optical concept, which means that, well, if any of you still remember middle school, sorry. That if any of you still remember middle school optics, it means that magnification is the ratio of your resulting image and the size of your original object. So assuming that we have a 2mm object, what you will have as an image is a 10mm image. Now back to our microscope. What 5x means here is that with our camera sensor, which has an image size of 36 by 24 millimeters, you're about to see 6 by 4 millimeters on the screen. And that's a ninth of your fingernail. This is something that I prepared. You may not be able to see it very clearly, but it's a piece of silicon, a computing chip that exists in basically every device that we use in the current day. As I turn this on, so you can see all the details, the transistors, the computing units, all on spreading over this little piece of silicon. Now, sorry for having a blurry screen here, but I mean, usually I do better. But it's a speech anyways. We're not here to see the microscope. But let's take a closer look at it as I return to my PowerPoint. Sorry. So this microscope, first of all, there is 30 by 30 aluminum extrusion profile. And you can see the camera on top. There's an extension tube around here, a tube lens here, and finally, the objective lens on the bottom. And then after many conversions, you connect all of this together, securing this to the main stem of our stand. And also, thank you, Nick. I think it's other way, but thanks for Nick providing the microscopic lens generously. And Although you can't see today, but that gray cylinder down here is sprayed with black paint so that when we usually get an image with not one of these staff plates, but an actual glass plate, you will have a perfect pitch black background resulting. And lastly, there's our specimen right under the lens, which in our case today is a computer chip. I'll put it aside right now. Okay. And when you hear me walk through all of these designs, all of these structures, these mechanisms, you will think that, yeah, it makes perfect sense. It's destined to be in this format, this design. But I'm going to tell you no. It took me 6 months from nothing to this thing, all right? And it all started from this. You can see that they're completely different things. The earliest thing was a tripod mounted with an overhanging bar. And then on that bar, we connected the camera onto another microscopic lens, which we put the specimen down below. Let's just say that it was a disaster. Yeah. Just imagine a spring. That's basically a spring. And then nightmarish, okay? Because you need to adjust your focus, and then there's no focus adjusting mechanism on that thing. You basically have to remount the whole tripod and then put on the camera again, and then hopefully that you can somehow find the focus. Usually you don't, okay? And the tripod and overhanging bar nature of this design ensures that it will wobble every step you took around this environment, this room. Not today. Anyways, after assembling this thing, I went back home and I thought there has to be changes made. So this is what I did. That very night, I worked till like 3 a.m. I modeled this stand. And then I 3D printed it and then also bought one of these height adjusting platforms, which you can actually using it right now. And I assembled everything together to make what's supposedly a microscopic stand. Now, the problem is plastic, right? You all know about plastic. It's pretty soft. So when your 1 kilogram camera setup relies entirely on this flimsy piece of 3D plastic, you know something's going to go wrong. And it did go wrong. Every step we took in that room with flimsy floor, the whole image was shaking on the footsteps. I mean, over the days, we did get some nice images. Not that we received nothing from it, but still, it was not enough. Even though I can show you a brief footage here. This is a growing crystal. I believe it is. Sorry, I forgot the English name. But this is a growing piece of crystal in a chemical compound. And when in the compound there is too much of that solvent, it will gradually crystallize and become something like this. And this is when you see the growing lifelike image of it. And I believe that this footage took us like 30 minutes to film, actually. So this process took more than 30 minutes to go through. And if you look closely enough, it's very wobbly. The whole image is, I don't know, oscillating. And it's definitely not something you want. So I got back home and thought, we need changes. So we did. First thing first, plastic. No more plastic, because plastic bends. So I was looking for metal material, and I stumbled into this. This is aluminum extrusion profile. It's an industrial standard grade material that allows you to cut, assemble, and configure in whatever way you want. And then I thought, I need a central stem, which is basically this part right here, which holds the camera onto the stand. And I was thinking, I should use a custom piece of aluminum parts. And I did model it, this thing. And I went to online shopping for a quote. Guess how much I got? 200 plus RMB. That's not acceptable. Like this whole stand right here is like 170, and that thing 160 plus. No, I'm not taking it. So I was like, if only there's some kind of way that I can avoid using this part. So again, I went for aluminum profiles. I remodeled the aluminum parts and then drilled holes so that it can hold the camera and its mounting plate, and also did computer simulations to make sure that it will have as good rigidity, if not better. And this was the resulting software design of it. You can see that they're basically the same. Well, but the design of a stand is not just, well, designing materials and putting it together in SolidWorks. There's so many details you have to consider. Like these mounting brackets, I chose like 4 different versions because of their different geometries, because I have to account for the little tolerances under its plate and the fact that how its geometry may stay up to external stress. I had 4 versions. I took hours investigating into their shapes and materials to finally make a decision. Similar for many other things. This 3D printed part melts under light. So I have to redesign it so that it has cooling, so that it won't melt under like 50, 60 Celsius when we have a light on. And also, you can see this black plate down here. It is a calculated carbon fiber plate because the original plate that I used was flexing so hard that I couldn't use it. I went to the software and computed everything, all the details, all the parts, and this is a light source that I did not bring today because we don't need it. And also, we have to choose from so many different kinds of designs, systems, optical systems. So on the left, you have a finite conjugate optical system. Right, you have an infinite conjugate systems. So this one is a finite conjugate system. We have the objective and the sensor, or the eye. And this thing, or this thing right here, is an infinite conjugate optical system, where besides the objective lens, you need tube lens, you need conversion tube, you need camera, and you need all kinds of different parts holding it all together. And also, the lenses are more expensive. Again, thank you, Nick. And that's the amount of engineering work that I did to reach all of this. It literally stuck my computer. But eventually, yeah, it did went well. For our macro chemistry project that I showed you before, these are some of the resulting photos. Some of these are crystals. Some of these are vitamin C's. Some of these are metals displacing each other in compounds. And some of these are other crystals. Comments? Thank you. You're breathtaking. Well, at last it turned into a school's exhibit. On that day of opening, I was more than proud. Words cannot describe my feelings. But since then, I keep reflecting on myself. I kept asking the same question. How? How did this thing even come together, right? I wasn't born to know microscopes, okay? Honestly, it was a fascinating story. Well, here's the take. It would have been impossible because for me, I'm an engineering nerd, okay? I admit it. And I have not looked at a chemical equation I graduated from middle school. Practically, I know nothing about chemistry. But then our friend, Daniel, he's the leader of a high school chemistry club. Wow. But he doesn't know about optics and engineering enough to craft a solution. And then there was Bob, which happens to be on scene today somewhere. He's planning to make film. Now, these 3 random people, they gathered in SSBS TV. And for those of you who don't know, SSBS TV is an organ which primarily focuses in photography and videography, where when there's in-school events or news, we take care of it, right? So all 3 of us were SSBS TV members. And there was one random lunch break where we got in and had a chat. It's like, And I was like looking at a screen protector, and I said, oh, that's cool. And then the other one said, you said you want to do some micro project, didn't you? And then I was like, yeah, maybe. And then Daniel was like, what about chemical reactions? I can take care of that. That's it. We finalized our ideas, we started planning, we started daydreaming, started drafting plans, and eventually we got this project done. Daniel, by the way. And that's it for our project now. But again, let's zoom out. Again, just to clarify, I did not get to know with aluminum, carbon fiber, and screws when I was. I did not get to know how to use a camera when I was born. And engineering was not part of my genetics. Yet, it was the clear path that I came along since the last decade, which brought me standing right here. And honestly, when I was young, I was different, okay? I was artistic. I was very young, and I liked arts and crafts. I was drawing, I was making handicrafts, origami, all that kinds of stuff. And then in 8th grade, middle school, I got to know with CG digital art. It was when you use software to build models and render scenes in the world. This is a model that I made 2 years ago. And you can then render it so that it would achieve some sort of effect. It was an artistic tool. And I was so passionate about it back then. I devoted countless hours. For this model, it was in summer's holiday, and then I took basically 8 hours a day or more, and then consistently for a week. So it's like 40, 50 hours every day sitting at the computer dealing with this. And this is what I kind of got. It's not even finished. There's still that big square you can see right there. Anyways, yeah. In the meantime, after fiddling with an ancient camera for a while, I got my first camera. Not this one, unfortunately. But again, I got into photography. But in that process, I was changing a lot. At some point, I thought CG and arts will be my future career, but as you can see from the microscope, well, that's unlikely to be true, unfortunately. Well, I gradually bottlenecked. I went to a bottleneck. I couldn't feel the passion. I couldn't satisfy myself with the amount of talent that I had, the skills I had. It wasn't enough for me. So I decided, maybe it's time to break. And I did take a break. But then at the meantime, something else struck me. It was robotics. A friend asked me about VEX Robotics, start of high school, if I wanted to join the school's team. Well, I thought about the self-designing robot, building, competing, and programming, and I was like, damn, that's cool. So I went for it. I joined. Oh, by the way, these were some of my creations back then. Photography. So I joined. It was 2 straight years into robotics, and I learned how to use software to design robots. I learned how to build robots with screwdrivers, and also I just had a great time with my friends. It was wonderful. Anyways, 2 adventurous years, highs and lows, mostly lows, I gotta be honest. We failed in most of our competitions. But then there were happy times, there were great times. At some point, we did win. And it's not that it's about the win, but it was a great experience. It was a great time of my life. What's funny is my previous skills in CG arts made me a very quick learner in designing these robots in software because I was kind of adapted to the kind of mindset where you deal with things in 3D software. Well, anyways, eventually, VEX brought me into the world of engineering. VEX equipped me with the ability to solve problems in efficient, innovative ways. And that is the engineering mindset, where you can clearly identify the need, identify what is being problematic, and then think for an efficient solution towards it. That's what I've been doing for 2 years for this. And the trail that I just took you through, well, is precisely what brings me here today. Arts and design, photography, 3 years in SSBS TV, 2 years in VEX robotics, and engineering mindset, all of these together enabled me to do so many things, and I DIY things that made my everyday life more convenient. And in our school's journal, Veritas, I helped with designing posters for advertisement. I made use of my engineering thinking to construct a more efficient workflow. I'm currently designing a tool that will save many hours spent in packaging the journals for delivery later this year. Maybe at some point you will see it. Who knows? Well, in fact, this very moment is at this year. Maybe at some point you will see it. Who knows? Well, in fact, this very moment is a display of what my experiences have brought me. The reason that you can see me on 2 different screens with captions, with translations, while also being streamed to the internet, while also being seen through screens, is that me and these wonderful individuals on site, these talented people from SSBS as well, we together managed to find an affordable solution to manage all of these, to record, to photograph, to live stream, to translate. Wonderful. Come on. To all those people. And yeah, that's it. I'm standing here. That's my story. That's my story for the last 10 years. A story of a boy who went through all of those things so that he can stand here today and talk about a random microscope. Well, after all, I'm not here to lecture you. I'm just here to tell a story. But if you want to take something away, if you want some takeaway, I would say that go for it. You know, when you have an opportunity, when you have a passion, just go for it. Don't hesitate, because that opportunity, you never know what it's gonna do to you, unless you look back at it. I don't know, 5 years, 10 years back at it. Well, yeah, just go for it. Because 4 years ago, I said no to my first invitation to VEX, and I still regret it to this very day. I said no to my friend because I was too interested in arts. I wasn't ready to take this new field. But then I thought, 2 years later, I'm gonna do it. I'm joining it, and this forms what I am today. And also, if it wasn't for that random talk about microphotography in SSBS TV, this project, this whole microscope thing wouldn't be a thing. And I wouldn't be standing here talking about it. So yeah, it's really adventurous when you think about it. Please, guys, be brave. Pursue when you can, for you will only know years later how much of that tiny moment of decision cost you will bring you. And as for me, I'm just happy. I'm more than happy that I took it. I'm more than happy I took the crossroad. Thank you, everyone. To our guests, audience, speakers, you are all wonderful. And also to our brilliant individuals who made TEDxSSBS possible. Thank you all. And thank you to that boy who said yes to Crossroads. Proud to be here. Thank you.